This next section for chapter 5.3 is studying enthalpy. So enthalpy is a common term that we will use rather than energy. It's more widely studied and reported on. And it basically gets used when a process or a reaction takes place at constant pressure. We only have pressure volume work happening, and so we can account for the heat flow through this enthalpy value, and it's the letter H. And you'll see why it actually ends up, I believe it used to stand for the heat, and you'll see why in a second. So H, just its pure value, is equal to the internal energy plus pressure times volume. So, but when we are at, again, constant pressure, then the change in enthalpy actually starts to break down. So just like energy, enthalpy is often measured by its change, not its value at a given point. And so what we're going to do is we're going to derive the value of enthalpy at constant pressure. So what we do is we take our delta H, so we're adding a delta here. Now we're going to apply the delta in. When we do this, it's not as simple as with traditional algebra. We actually say we apply the delta in and we do delta E plus pressure times delta V. So we're going to apply the delta to the P and the V. So here I applied it to the V, and then I'm going to do plus pressure, delta pressure times V. We do know that we are at constant pressure, so there shouldn't be any change, so that one just goes away, which is nice. So we have our enthalpy is change in energy plus pressure times change in volume. But now we're going to actually break down the energy term. We know that energy is equal to heat plus work, which we're also going to break up work. Remember, work is negative pressure times change in volume. So we end up getting here that delta H equals heat here plus or minus pressure times change in volume plus pressure times change in volume. And hopefully you can see that these terms both cancel, and we get that at constant pressure, the enthalpy is just equal to the heat, which I believe is why it has the letter H instead of like a different term. This is a pretty valid approximation because if you think about when you do a reaction, maybe you do like the vinegar baking soda experiment where it gets all bubbly, gases get released there, but they open up to the atmosphere, and while the pressure technically would have gone up, it would be so significant because our atmosphere isn't going to change by that much based off of a simple reaction that you did. So we consider a process to be endothermic when the enthalpy value is positive, and a process is exothermic when the process is negative. So again, if heat goes into the system, it's endothermic. If heat leaves the system, it becomes exothermic.